In this video I'm going to show you how you can record your data direct to disk. With Vicon Shogun we've introduced an MCP file, or mocap file. This file contains a copy of the current calibration, active subjects and real-time data, along with paths to the X2D and any video cameras you may have in the system. This mocap file is designed to bridge the gap between what you capture in Shogun Live and how you take the data into Shogun Post for cleanup. I'm also going to cover the different recording options and problems that may occur with your real-time data. As you can see, we've got our subject calibrated and ready for capture. We've got a view video camera in our system, and we're using the 3D overlay to see the mesh and live video combined. This is a really useful workflow for making sure your solve looks correct. If we go to the capture pane on the right, we can see various options for recording our data. The first thing to check is to make sure we're recording the data into the correct folder. Using Eclipse, we've created a session folder to record to. We also have the option to increment the take name. This is a useful feature if you're going to be capturing multiple takes of the same move. We can then name our take and add a description, along with any comments to the capture. It's worth noting you can also add comments from within Eclipse once the capture is complete. You can see we have options for capturing video and process data. If you're using a view or beneath a video, make sure to tick the capture video button. The video files and overlay can also be viewed in Shogun Post, and it's a great way of checking your data. The processed data includes the 3D labels and solving bones that make up our unbreakable real-time. For now we're going to record this take, so I'm going to click Start Capture. In the past, this data couldn't be stored, and you essentially had to start from the beginning in post. With Shogun you can now record this data direct to disk at your source frame rate, in this case at 100 frames per second. You can see the bar across the bottom of the screen sometimes displays red marks. This shows you when the real-time system can't keep up with the target frame rate and has to drop a frame. You can see the percentage of drop frames across the bottom. Don't worry though, unless this number gets very high, it's still okay to capture. The original X2D data from the cameras is always being recorded, and you can make use of it to fix drop frames in post when you load the MCP file. If you see a large number of drop frames, say above 30%, this is generally a sign that your system is out of calibration or can't keep up with the current amount of data being processed. In this case, you may need to recalibrate, or even upgrade your PC. It's worth noting Shogun is designed to work with new multi-core PC technology. Under Auto Capture, you can see options for starting and stopping using a particular timecode value, along with the ability to trigger external sources, like a Vicon Kara HMC system. You can also have Shogun Live be triggered from an external source. This is useful if you have your own capture tools running on a separate PC. For more information on triggering Shogun remotely, please refer to the Shogun Live SDK video. Finally, we'll see the capture buffer size. This represents the amount of memory allocated to Shogun Live's captures. We've set this to 2 GB by default, which should be enough for most situations. If you're using multiple video cameras, you may need to set it higher. It's always recommended to record your data onto a fast SSD drive. In the data capture pane, we can see the current timecode being received along with the green icons, showing us that we have genlock and are running at PAL. This area is also used to display if there are any issues with the capture, so if a video camera fails mid-capture. You can see on the left-hand side under processing we have 3 different processing levels: reconstructions, labels and solving. Generally you would always set this to solving, as you want to record the label data along with the solved skeleton bones underneath, but if you're only interested in markers then you can choose labels. Reconstructions is generally just used to troubleshoot your data. Under advanced options we have a number of settings that cover things like marker size, the number of cameras needed to see a marker, and environmental drift tolerance. This setting helps if you have a calibration that is slightly off due to a change in temperature. There's also a setting called smoothing factor. This value affects the way the labeling skeleton is used to fill any gaps or occlusions in the data. If the data is too high and you have fast moving data with gaps, you may see the data become spongy during fills. Anything between 25 to 200 can be used, with the lower values offering tighter fills at the expense of potential mislabels. There is also an option for occlusion fixing. This is recommended to be on as it fills in any missing marker data during heavily occluded actions, as visible here. Traditionally the real-time would collapse during these actions, but thanks to occlusion fixing they are now not only achievable, but also maintain the original movement of the performer.